is the next question, which says that fx is x squared plus 1, gx is 2x minus 5, hx is 2 power x, and the domain of fx is all real numbers. Write down the range of f. Okay, so fx is x squared plus 1 with a range of all real numbers. That means all possible numbers on the real line. So then what's going to be the range of fx? The easiest way of doing this is visualizing the graph of x squared plus 1. The graph looks like this. This would be 1 because the graph of x squared goes 1 unit up. So from here we can tell that the range of fx is greater than equals to 1. All right, moving on to part 2, which is solve the equation fgx is equals to g inverse 50. Okay, let's find fgx first. So in f, we have to substitute gx. So it's going to be 2x minus 5 whole squared plus 1. And then we're going to equate this to g inverse 15. Now, what is g inverse 15? First, we'll need g inverse. So g inverse is going to be x plus 5 upon 2. I've done it in one step. I've done it mentally. 5 will go to the other side, get added. 2 will go to the other side, get divided. Okay, so g inverse of x is x plus 5 over 2. Just give me a second, please. Okay, so g inverse of 15 is going to be 15 plus 5 over 2, which is 20 over 2, which is 10. So now we're going to equate this with 10. So 2x minus 5 whole square plus 1 is equals to 10. It's in completed square form, so it's easier to solve it this way instead of expanding 2x minus 5 whole square, then rearranging, and then solving through middle term breaking. That would be lengthier. Instead, what we'll do is send 1 to the other side, get a 9. Then square root both sides, we'll get 2x minus 5 equals plus minus 3. And then we get x is equals to 8 over 2, which is 4, or x is equals to 2 over 2, which is 1. Okay. Next part is part 4. On the same axis, sketch the graph of hx and the graph of h inverse of x, indicating clearly the graph representing h and h inverse of x. Okay. So we know that graph of hx and h inverse of x is going to be a reflection of each other on the line y is equals to x. So the first thing I'm going to do is draw the line y is equals to x. It has to be a dotted line because that's not part of the original graph. Okay. Next, I'm going to draw the graph of the exponential function y is equals to 2 power x. So you know that from O levels that it starts from here, shoots up like this, and cuts the y-axis at 1. Now a reflection of this graph would look like this, and it would cut the x-axis at 1. So we have to label hx and h inverse of x. So here it is.